a warning for people that are now like, oh, Peter Naur, epic. He gets a bit crackpot in the end. But this paper is very reasonable. He's not saying anything, I think, that you can easily find that programmers would disagree with. Hello, this is Felienne.
And this is Hanna.
And this is another episode of Computer Science, of course.
Computer science.
Of course. Computer science.
Of course.
This is Computer Science.
Of course.
Of course.
Hi, Felienne.
Hey, Hanna. What do you know about Peter Naur?
Oh my God, you're putting me on the spot here. I don't know much. I think I once read a paper, so he must be some computer scientist, which might be the case, or a professor in computer science.
So he is a professor in computer science, and I think most people know him from the Bacchus-Naur form. That's also what I knew him from. And this is a way to describe programming languages. And fun fact that I found while I was researching for this episode is that later in his career, he really sort of railed against formalisms in computer science to such an extent that he didn't want to be associated with this formal description of programming language anymore. And he'd rather have it being called Bacchus' normal form. So he wanted his name of the thing that he was famous for, and that ultimately he also won a Turing Award for in 2005. So he sort of, as like a little Wittgenstein, he changed his mind. He's like, oh, here's some formalisms, and then devoted from the mid-'80s, which is also what the paper is from that we're going to read, devoted his career to saying, well, formalisms in programming actually are not so useful as people make them out to be.
Wow. Okay, I didn't know that. So you already mentioned a little bit, we're going to read a paper from him. What paper did you
Yes.
bring for us?
So it's a very brief paper. It's only 10 pages, and it's called Programming as Theory Building.
Okay, and I guess I want to know, why should every computer scientist have read this paper?
So what I think is really interesting about this paper is that it really presents a different view on what programming is. It's sort of already there in the title. It says programming as theory building. And he explains this in the paper as well. So theory here must be understood not as like a theory of gravity, but if you have a theory about something, he says, then you know what the thing is. Let me read a little bit for you. So he says, theory must be understood as a person having the knowledge not only to do a certain thing, but also to explain it, to answer questions about it, to argue about it, and so forth. A person that has a theory is prepared to enter into such activities, whereas a person trying to build a theory is trying to obtain this. So he says true programming, it's not really like programming is solving a problem. It's more like true programming. You are learning about the problem and you're also learning about the solution. And then if someone later asks you, hey, why did you implement this app in a certain way? Then you have the answer ready. You can say, well, I did it like this because, I considered 5 alternatives and here are reasons why I didn't pick those. And then this is the only one that was left. So the role of programming is to understand a domain and to understand the solution to such a level that you really, really are ready to defend and explain it. And I think that's not usually how we look at programming. Usually it's much more, well, there's a thing I want built, I built the thing, the end.
How would we then call this approach? I build a thing, I type some code. That's not programming in his way. So is that then coding, and there's a difference? Or
yeah, so he doesn't really go into that difference. I'm also not sure if there is a difference. I mean, I think always, if you are programming, you are always theory building. I think in many cases you're like, oh, do I take a set or do I take an array, or what kind of database do I use? So every line of code is a decision, and every decision has a reasoning. So I think even if you're doing something relatively straightforward, then still you are deciding what is the name of this variable. And then all these stories, of course, in your brain, some of them you might actually remember. And some people might ask, oh, ask you also in a code review when you're submitting a pull request. They might ask you, is this a good data structure? Is this a good name? And then, of course, you remember extra well.
Yeah, no, that makes complete sense for humans. The reason I asked the question is I was wondering what is an LLM then doing? Because for me, it's really not programming then. It's doing something else because it's not theory building, an LLM that's coding. So I just wanted another word, and I would actually like it if there were another word for humans doing programming
Yes, I
and
totally get that. I
LLMs.
was also, of course, thinking the same thing, right? You cannot read a paper in 2026 and not think about AI. So I was literally next to a similar passage in the paper writing down, and AI does not have this.
Yeah, exactly.
He does make one difference, actually. If you want to have a new word or a new term that you can use, Peter Naur here is building upon the work of Ryle. He's a cognitive scientist. Um, Side point, I also really like this. So, what I know from other papers, from computer scientists, going back to Alan Turing in the original Turing test paper, is we don't really know much about other fields, right? This is one of the goals I think I have with this podcast, to explore different areas and to make computer science richer. Nauer actually does this really nice because he cites his sources and it looks also like he read the sources. So he's working here building on the foundation of the concept of mind from Ryle. And this Ryle guy, I'm assuming he's a guy, has a distinction between an intelligent activity and an intellectual activity. And he says that in intelligent behavior, so this is not just intelligence, but intelligent behavior, the person displays not any particular knowledge of facts, but the ability to do certain things, to make and appreciate jokes, to talk grammatically, or to fish. I really like this broadness of things, but this is also true, right? A person
Yes.
can fish and also
Yes.
produce sentences. And he continues that intelligent performance is characterized in part by the person's doing them well according to certain criteria. And displays the person's ability to apply the criteria, to detect and correct lapses, to learn from examples, etc. So I think this is actually a very useful distinction. So what is just intelligence is knowing facts, right? But intelligent behavior or intellectual activity, as he called this, is also knowing when something is good, right? We are programming, we look at code, and then you look at it and you're like, yeah, I don't like this. My husband is a professional programmer. And sometimes we embark on projects together and I do something and he looks at it, he's like, no. I'm like, why not? He's like, let me think. And and then of course he has reasons. I think this is this ability to apply criteria. And then he has some reasoning about optimization, elegance. I think this is very recognizable. And you have a consistent way of doing this. And maybe there's also some criteria that are on intention a little bit, right? You want um, elegance, but also you want performance, and you can't always have them both. So if you are looking in AI to make this difference, I sometimes use this distinction also in talks. And I do think intelligence is different from intellectual activity or intelligent behavior.
Yeah. Okay, I'm glad we could use this immediately and apply it to a current thing in the world. So this paper uh, has somehow maybe foreseen also some of the things that are happening now. I don't know what was going on in AI when this paper came out.
Yeah, so it's the 80s, so it must be a little bit this AI winter, where of course they try it, and this is maybe this undertone that you feel here a little bit as well. This early AI really tried to grab everything into rules and systems, expert systems, where based on facts that you would put into the computer, an answer would be calculated to a certain extent. Sometimes I explain this to students as like a calculation machine with facts. But that didn't really work because the world is so multifaceted and it's really hard to get something so formalized. And then, of course, what we have now with this AI hype is we indeed lost the formalism, right? We're no longer trying to model the world in rules. We're just doing it more or less. And that this helps with getting it right, but then also it remains to be more or less.
Okay. And what are the implications of this view on programming? So if you don't see it the traditional way, but more as like gaining an understanding of a problem and of a solution and maybe building a mental model and really, yeah, thinking about the thing. What does it mean for computer scientists, for programmers, for software, for companies?
Yes, that is a great question. So first maybe the answer without AI, and I maybe also have one with AI. Um, so I think what you see with just traditional programming tooling like an IDE is that it is not built with this view of programming in mind. An IDE is meant to make code and run tests. But nowhere can you store information about this thinking process. I have a friend, Greg Wilson. He's also a programmer. He wrote a few books on programming. And he's always said that it's so weird that in an IDE you can't draw diagrams. That's if you open Visual Studio or whatever, any of the IDEs, um, you can't just take your mouse and draw something, even though drawing something is something we do on whiteboards. We have mental models of architecture diagrams. Why can't you just draw it on top of code, right? I think this is an excellent question to which there really isn't a great answer. And this paper somehow helped me to formulate that answer a little bit. Because if you see code as something that must be produced, then our IDEs fit really well. But if you see code as a process through which you're learning, then the most obvious next question is, okay, where does the learning go? And Naur also says this in his paper that, again, if you're this person that holds a theory, then the knowledge you have transcends documentation in three essential areas. And then he talks about this explanation, the why, having the theory, that you can also constructively talk about modifications to the program. And I think we all know changing code is really hard, right? Writing code is fine, but then a customer or yourself in the future is like, oh, but can't we also add this, right? And I think everyone that programs has been in this conversation many times. And then sometimes you say, no, because, right? Or you can say, oh yeah, that would actually be really easy because. So reasoning about modifications, all these type of information currently, as we've organized software, only exists in your brain. And you can't really dump it anywhere. And also, of course, I am the maintainer of a big open source software project. I have also been in this situation where people ask me to do a certain thing, changing the grammar of our programming language, for example. And it was like, I am the only person that can do this. And they're like, but we have so many other people working on this. I'm like, yeah, trust me. And this is also shit, right? This is not the position you want to be in. I would very much like to say, this is where the code is, this is the change you make, go. But some of the parts of the code base are only in my head. So I think from that perspective, we would build different software for building software if this would be our mental model of mental models.
Whoa. This is crazy. It reminds me of the software we use for qualitative research. We have, for example, Atlas DI. It has this
Yes.
little memo feature. So you do your analysis and then you write memos to yourself in which you can reflect or describe why you made a certain decision or why you merged certain codes. And codes in this context has a very different meaning. But in any case, my point is there you have a little bit this function that your reflection has a place in the software. I could play a little bit advocate of the devil and say, yeah, but you could try it in comments in the code to a little bit get your explanations, your reasoning, your motivation, and a bit more of your mental model there. You could even draw ASCII art if you really want to
Yes.
draw.
And people do this, right?
Yes. But yeah, it's very fascinating. I want to give my students now the assignment to build an IDE with this starting point and this understanding of
Yes. And
programming.
yeah, I think this is also why it's such an interesting paper, because on the one hand side, as a programmer, you immediately understand that everything he's saying is very reasonable. This is not true for all his later writing. A warning for people that are now like, oh, Peter Naur, epic, it gets a bit crackpot in the end. But this paper is very reasonable. He's not saying anything, I think, that you can easily find that programmers would disagree with. So, but on the other hand, you're like, wow, I have never looked at programming like this, right? Even though I know this is a thing I do, of course, if you're programming, you are theory building, having a vocabulary for it. And maybe that's also interesting to circle back to a little bit of some of his later work. For example, in his the lecture he gave when he won the Turing Award, he says that we do in computer science too little description, just describing things. It's like, oh, we're always so concerned with hypothesis and this causes this, right? Oh, if you program like this, then you get a bug. He's like originally an astronomer. And I think maybe you see this as well, because of course in astronomy, people don't do experiments. It's just like, oh yeah, we bring a little sun into the lab and a few stars. We see what goes on. And so astronomy is very much focused on very precisely describing what's going on, giving names like this is a black hole, this is a dying sun, or sorry for astronomers in the audience. They give good words to valuable things. And that also this paper does, right? It gives us a vocabulary to talk about something without necessarily hypothesizing or building or constructing.
Yeah, so what method does he actually use in this paper? How would you call this?
Sitting down and thinking and then writing.
I love it.
Yes. You and me already talked about this often. That's how does computer science produce knowledge? It's very often through building, right? And through writing a proof or code. But other fields, many of them, their strategy is just look at a thing that exists in the world and describe it really well, and then work with the implications of a system or a framework, we would call this, that you just described. That is something that feels very weird for us. So, I mean, I was just saying no one would disagree with this. Maybe I should eat my words. People are like, where's the evidence that this actually happens in your brain if you're programming? If you come from that way of thinking, then you might not necessarily disagree, but then that might be a weakness you can see in the paper.
Okay, and the way I understand your summary, it had kind of a research question that was implicit, or like the way I understood it, it sounded like the question is what is programming, but it's not an explicit question. It's more like
Yes.
the
Well,
topic
it
of.
is actually it is quite
Yeah.
explicit. On the first page, he says that it is important to have an appropriate understanding of what programming is.
Ah,
So we just really call it a research question because that is a bit weird if you don't do empirical work typically. But he is saying if our understanding of programming is inappropriate, then we will misunderstand the difficulties that arise in the activity of programming, and our attempts to overcome them will give rise to conflicts and frustrations. And next to this, I wrote AI, AI, AI. Right, because I do think this is maybe this answer I promised you before, about I will give the answer with AI. That because we have come to see programming as producing code, even though of course many people, including Dijkstra a long, long time ago, said, writing code, it's about spending lines, right? You have to be careful not to make too much code. Um, Even though we all sort of know that's not true, writing code is producing a lot of lines of code. And then if it works, we're happy. Because of this view, AI can be seen as somewhat successful because it can produce code, which sometimes works, which is also what is true for some programmers. Because, of course, programmers also make mistakes. This is what people then say. Well, the LLM hallucinates, but people make mistakes, so it doesn't really matter. If everyone would subscribe to the notion of programming that Naur presents in this paper, then AI would be useless by definition, right? Because the goal, he says, is for you to understand the problem such that you can reason about the problem. This is not happening. The opposite, you can say, is happening through AI, where AI produces code and then you have no understanding. You are not ready to defend any decision. Like, hey, Felienne, why is this bug there? I'm like, Claude did it. Claude did it. I don't know. So you have no hypothesis or theory. And also, if someone would ask you, hey, can we add this little feature? Like, I will get back to you on that, right? You cannot immediately, from your knowledge of the architecture, reason about whether that will be easy or hard. So I think that is a useful way also. If people say like, what are we losing by programming with AI? I think this is one of the things that we're losing. You will then work in a company potentially if everyone is vibe coding and using their agents to produce code in which no one is ready or able to really defend the architecture of a system, except for another system, which is Claude Code or ChatGPT or whatever. It doesn't really matter, of course, what system you use.
Okay. And you just mentioned AI in the margin. Did you have more interesting things in the margin and any sentences underlined or highlighted?
Yeah, so in some cases, I was also not 100% in agreement with him. So he says, this is sort of the answer to this question, what is programming? He says, programming is the whole activity of design and implementation of programmed solution, the activity of matching some significant part and aspect of an activity in the real world that can be done by a program on a computer. And then, so I wrote next to this, but what do we do with worlds that do not fit into the computer, right? So there is some part of, sometimes you're creating something on the computer, right? So maybe this is this thinking of, there's stuff like an insurance company or a factory, and we're just automating what already exists in the world. But I think in many cases, that's not really the software we make anymore, right? In so many cases, the worlds we are creating are the digital worlds. Like, what is the mapping of a tweet or a skeet to the real world, right? It's not like I have a robot arm and this motor now also exists in the computer. It's like a
Yes.
tweet is a thing that we invented in a digital world. So this mapping of the real world to the symbol manipulation, he says, I think that breaks down in a world where we have social media or Uber or Airbnb, like there isn't really a physical thing that we're modeling. So I was wondering, how does that change the paper? Does the paper change? Because I see how if you're building a robot arm, you're learning about how the robot arm works, and then you know, oh, this servo can go this way, but not the other way. Whereas if you're building a social media app, what kind of knowledge are you gaining? Not necessarily about the architecture, right? Of course, that is you're learning, but are you also learning about the impact of the thing in the world? So there, it's like, I need to think about this a little bit more. And weren't you teaching a requirements engineering course?
Yes.
I have one for you, my
Oh,
friend. Yes. So he says something about the use of a program will inspire further useful services that the program ought to provide. And I think this is also recognizable, that you build software and then you start using it or your customer starts using it. And then they're like, hey, but if we have this, can we also have this? I wrote down in the margin, yes, a requirements engineering course should cover this.
but this also already also partially answers my next question, which was where in a computer science curriculum would you want to see this paper? In which courses could it be at play? So requirements engineering is one. Nicely spotted.
Yes.
Where would you put it if you get to make your dream curriculum?
Yeah, so a software engineering course would, of course, also make total sense, where in all sorts of little projects that students do, we could ask them, we could teach them this behavior. Like, okay, you just programmed for 1 hour. Now, like Atlas TI, right? Now, here's a memo. Write down the things you learned. Or make a little video, right? Live stream yourself. For all I know, this might be very interesting for students these days. You will program, you will live stream your programming, and then you will rewatch yourself and then note down all the decisions. I think that will be so much fun and such a useful exercise, because it's very hard to do while you're doing it. You're in the zone and you're already thinking about the program. So then you're not like, oh, wait, stop, right? Write down what I'm thinking and then go back. And I think it could also be really nicely done in pair programming, where if there's two of you, one person is programming and the other one, the navigator, is saying, this is what we will do. These are also decisions. So I think these are places where it will fit, I want to say, effortlessly, right? Without making a lot of changes to the curriculum. But it's very hard to do these things. Now here's the but. I'm working on this notion of how a computer science program is organized, and that sometimes we do a certain damage to students that later needs to be repaired. So I think that fits here as well. If your introductory programming course is, let's reverse a linked list, right? Let's find the longest alphabetically ordered substring in this text file. If that is what we, I mean, these are, you are laughing, but this is literally what people still do, right?
I'm crying on the inside.
If that is what we do for 3, 4, 5 semesters, and then there's a programming course in which Wicked Hermans or Wicked Schravenberg are like, but we would really like you to think of your mental model. That'll be really hard to get in. So there's like the ideal world that we would live in. This would be one of the ways of like, hey, this is programming 101. Programming can be problem solving. Programming can be theory building. And I'm sure it can be many other things as well. That world is very far away. So in the world that we have, I would say have students practice this in a few project courses.
Yes. Yeah, and I definitely would want to have it as a thesis topic with the IDE, where they actually build a new one based on this idea. Yeah. Is there anything you want to say about this paper that we didn't discuss yet?
One more quote, just to leave it just again in the AI hype. The main claim of the theory building view of programming is that an essential part of any program, the theory of it, is something that could not conceivably be expressed. He means by formal methods in the code. It is inextricably bound to human beings.
Beautiful. Yes.
A big
Indeed.
heart.
Yes.
For Peter Naur.
Yes, wonderful. That is a great way to end this episode, I think. But do you have maybe a homework for someone who wants to, I almost said delve in, that I won't say.
The word is toxic now.
Yes. For someone who wants to go deeper.
Yeah, so I mean, read the paper. It's very short. It's very doable. And I do think this exercise, I will admit, I have also never done it, where you are programming in a as realistic setting as possible, so not reversing a linked list. I think it would be absolutely amazing to just try, after you're done programming, take one sheet of paper and try to write down all the decisions that you just made. I think that would be so useful, such a useful way to maybe start writing a pull request or writing some documentation, right? Because so very often in the code, it's just a code, or in the pull request, it's just, oh, I added this feature. Yes, but why, right? And specifically, what things did you consider that didn't end in there? So often I'm like, oh, why didn't you do it like this? And people are like, well, actually, right? Maybe we write this down so that it is already somewhere. And then from this, maybe also an overarching architecture evolves. I think that would be sort of easy homework and super useful. I would be gladly hearing from people that tried this if it works for them and in what way.
So, Felienne, do you already know what you will bring next time?
Well, I have an idea, if you're okay with it. There's a book called Computers as Theater by a theater person, someone that has majored in theater, explaining how using a computer is like being an actor in a play.
Wow. Yes, let's do it.
That is very much, of course.
No, theater sounds good. Let's do that. Okay. I will stop the recording. Let me click stop. Hey Felienne, it's me again, Hanna. It has been some time since we recorded the Peter Naur episode, but I finally did the homework and I just wanted to leave this message with my homework so I'd remember and I can share it with our listeners in case they also did the homework or want to go deeper. But of course, completely fine to just skip to the end of this episode and start right with the next one if you don't feel like doing the homework or discussing the homework. So first, of course, I did the homework reading, which was the reading of the paper Programming as Theory Building, which should not come as a surprise because this is our episode 1. And yeah, not surprisingly, I liked it a lot. I was like clapping in my head enthusiastically while reading it. So, for instance, I couldn't agree more with his conclusion that, and I'm citing him here, the notion of the programmer as an easily replaceable component in the program production activity has to be abandoned. I believe this is more relevant than ever with people constantly arguing that programmers can be replaced by AI. But of course, I could not switch off like this critical voice in my brain that starts complaining whenever I read anything. So let me just share some of the loudest complaints of criticism I have. So the main issue I struggle with is how this theory that programmers develop according to Naur is presented as something that can only exist in a programmer's brain. It can be only obtained by programming and then it is part of the team of programmers. It is not something that can be shared or transferred to other programmers or other teams or documented or written down. And I know you were super excited in our recording about this because it makes it so human and it's something LLMs can't do. But I also believe that with some efforts, part of the theories that programmers build can be expressed and communicated and shared and transferred and documented. And I think that's also something we do when we educate our computer science students. We try to convey some of these theories. And I think, in fact, Nauer himself provides an argument for this possibility of transferring theories when he draws on this analogy of Newton's theory of mechanics. So, this understanding of Newton theory was possible for people to understand by studying its documentation, by studying the writings, by watching YouTube videos. So, Newton's theory of mechanics was not constrained to Newton's brain, he could share it with others. And just from reading the paper by Nauer, I don't see yet why the theories programmers come up with and programming should be so fundamentally different that they can't be shared, or at least parts of them can't be shared or expressed or documented and so on. So I think that is something the paper could have clarified a bit better for me. And maybe that's just because I'm not really a programmer that I don't immediately get this, but would be interesting to me. Of course, I also reflected on this paper from a current AI perspective. We've already discussed this in our recording together. And I have highlighted one more thing that I found particularly relevant to this current age of AI. Namely, Nauer points out that when solving real problems, the programmer knows how their solution relates to the aspects of the world that it aims to address. And as he puts it, the decision that a part of the world is relevant can only be made by someone who understands the whole world. And such a true understanding of the world arguably does not exist for coding AIs. And while Nauer talks about the world in a way that suggests he means the physical world, I think the same point can be applied to digital aspects. So even if one programs a solution for a social media platform or another digital service that an AI could, in theory, know inside and out, decisions about what factors are relevant and not relevant can only be made by someone who understands the environment and the real world context in which such a product will be used, the real world and real humans who use these services. So an AI can't do it. An AI can't program, definitely not in our sense of programming. Yeah, so much about that. Whew. Yeah, then the part 2 of the homework. So for part 2 of the homework, I indeed did some programming. I did not exactly do what you asked us to do, where you sit down and reflect on our decisions afterwards. That's because I'm really not experienced as a programmer, and I decided to follow a tutorial instead. And I thought maybe in this tutorial I can spot some decisions, and maybe the tutorial explains why certain things are done the way they are done, and then I can spot some theory building here and there. So as a concrete project, I decided to build a Pomodoro timer to help me focus on reading papers, like for example, Naur's paper, without getting distracted. One thing I noticed even before starting any particular tutorial is how many Pomodoro timers exist on GitHub and similar code collaboration platforms. And I think the activities on these code collaboration platforms to some degree might contradict what Naur is describing, because he really mentions that taking over existing program tags is difficult and frustrating and time consuming. And while this might be true, still many programmers fork projects on GitHub and they don't start over, they reuse existing code. So it might not be that frustrating or that problematic or that difficult or not that important to really understand the theory that well, because if it really were that frustrating, people probably would just start fresh. Yeah, so then I followed one of the Pomodoro tutorials and that was partially successful. And I was quite excited because sometimes I felt like I could actually spot some theories that were going on in the author's brain. For example, there were some choices about how to communicate the passage of time. And that to me suggested some underlying theories about how humans perceive time. And also the timer had 3 states, work, short break, long break. And this, in my opinion, reflected or revealed some underlying behavioral theories, psychological theories of focus, attention, motivation. And these existing theories found their way into the Pomodoro technique, and then this technique was translated into digital tools. In any case, I think often when we program, we make use of existing theories from cognitive science, behavioral science, psychology. We do this in HCI all the time. And then in these cases, maybe programming is primarily also about translating theories rather than building theories. Um, of course, one doesn't contradict the other. Both can happen at the same time. But I think for me, it's important that we don't restrict programming to theory building, that we say it contains theory building, but it is more than that. And I think that didn't come across sufficiently in Noah's paper. Yeah, then after following the tutorial a bit further, I noticed that at some point I completely lost track of what was happening. So it felt like building this house in the trees without any idea of the tree, and then feeling increasingly uncomfortable with that. And so eventually I decided to throw out the tutorial and start from scratch. And I wrote my own little program. And of course, fascinatingly, this is exactly what Noah's article would have predicted. So he predicts that this is frustrating and difficult, and that usually it's better that a programmer starts afresh. So yeah, he was right. And then yeah, I observed my brain and what kind of theories and knowledge did float around in my brain when solving this programming challenge of doing a Pomodoro timer. Well, I have to admit, most of these insights and realizations and decisions, they were more about myself, maybe because I was programming this tool for myself. So, for instance, I realized that personally, I really like it when timers count up rather than down. So, when they count up, I feel like I'm reaching a goal and I'm coming closer to this goal. And when they count down, I'm feeling like I run out of time and I am running against the clock and I have to beat the clock. So, that was more like a theory about how I work myself. Um, then many insights didn't really come from coding, and many decisions weren't really during coding, but when iteratively trying it out and changing things. So I would try the program out and I would realize, no, that's not what I want, and change it. And this, I think, this idea of trying out the program with a user or with many users, ideally, and updating your beliefs and theories about what works and doesn't work is such an integral part of programming. that did not get enough attention in Naur's paper, in my opinion. So Naur's paper is still very much focused on the programmer as the human involved in programming. And I think we really need to focus more on the user as a human was involved in this programming activity. Um, yeah. Whew. So yeah, looking back, I think I wrote some rather bad code, but I think the resulting timer suits my needs. Uh, when I decide to read a book or paper, like for our next episode, for example, I will turn it on and then I will be disencouraged from getting distracted. In case you want to use my weird Pomodoro focus tool, we will put a link in the show notes. I'm looking forward to the next recording, to our next read, to the next homework. And of course, if you also did the homework, we would love to hear from you and your experiences. Looking forward to next time. Bye.